In this video, we are going to look at two special types of triangles and how they relate to trig. The two triangles are the 45-45-90 and the 30-60-90. So let's start with the 45-45-90 triangle. 45-45-90 essentially means that you have a triangle that has one corner at 90 degrees and then the other two are the same. They are 45 degrees. Now, let's assume, so we are going to assume that our triangle sits on the unit circle. Now the reason why I want to make that assumption is because if I assume that the triangle is sitting on the unit circle, then I can assume that this length is 1 unit, which means I can also assume that its matching length is also a unit. In doing that, I can solve for the hypotenuse here. So if you remember a squared plus b squared again, so a squared plus b squared equals c squared, we're going to end up with 1 squared plus 1 squared equals c squared. 1 plus 1 is 2, so your c value equals the square root of 2. And that is what this hypotenuse is the square root of 2. Now the reason for making this assumption is because we can now identify our trig functions, and I can identify them a lot easier than if we assumed that these values were something different. So here we know that we can start with the sine, and we're going to look at the sine of 45 degrees. So in this case, we're not just looking specifically at, say, the sine of theta, we're actually giving a degree measure to it. So we are looking at the sine of 45 degrees. So say we can look right here. Sine is opposite over hypotenuse. So we would have 1 over the square root of 2. Make sure you rationalize, which is going to end up with square root of 2 over 2. Now we can do the cosine, again, of 45 degrees. And it should end up being the same. Why? Because these two lengths, opposite and adjacent, are the same length. So here this should also come out to being square root 2 over 2. Now we have the tangent of 45 degrees, and the tangent is opposite over hypotenuse, or opposite over adjacent, which is 1. And then we have our others. So we've got the cosecant of 45 degrees, and in this case that comes out to being just the square root of 2. We then have the secant of your 45 degrees, ends up being the square root of 2. And we have the cotangent of the 45 degrees, which in this case still ends up being 1. Now because this is a special triangle, these trig measures here, as long as your legs are 1, these are kind of set in stone. They can be applied to the unit circle, but they can also be applied to any 45-45-90 triangle that you may be working with. Okay, so this is the root idea. In other words, this is your definition. Now, working with the 30-60-90 triangle is slightly different. The reason for that is because the 30-60-90 triangle stems from an equilateral triangle. So what I did here is I dropped my vertical line here in the middle, giving this my 90 degrees. And so since my one angle is 60, being that that's the definition for equilateral, that cuts my little angle down to 30. Okay, so here I have my 30-60-90. So if you look, this would be your 30-60-90 triangle right in here. Okay, since they're the same on both sides, that's what we have. Now, this being said, for this triangle, I would assume, So here we're going to go ahead and we're going to assume that all legs of the equilateral triangle were 2. So what that means is I am assuming that this big side is 2, that makes this big side 2, that makes this big side a 2. Okay? Now, if we assume that this length down here was cut in half, and I'm assuming that this length right here was a 2, then that means that this little piece right here has to be a 1. And now if this is a 1, and I need to find my missing piece, again, I would use Pythagorean's theorem. So in this case, I've got a squared plus b squared equals c squared. Here I would have a squared plus 1 squared is going to give you 2 squared. So in this case, a is going to be the square root of 3. So this height side is going to end up being the square root of 3. Just like before, once you know what all of your lengths are, you could go in and you can actually give your trig rules. So we're going to start again with sine. And in this case, we're going to start specifically with the sine of 30. So we're going to use this 30 right up here as being our reference point. And so with the sine of 30, this means we're going to have opposite over hypotenuse. So this is going to give us 1/2. Now we need to do the cosine of 30. So this is going to be adjacent over hypotenuse, so square root 3 over 2. Tangent of 30 is going to end up being the square root of 3 over 3. My cosecant of 30 is going to be 2. My secant of 30 is going to be 2 square roots of 3 over 3. And my cotangent of 30 is going to be the square root of 3. Now notice all of these were just of 30, but if you look at this triangle, I have another angle. So in this case, I also now have to look at what is the sine of 60 degrees, because they're not going to be the same. If I look, my 60 is down here, so if you look, that changes my opposite. So here, my opposite is going to be the square root of 3. My hypotenuse is still a 2. So this is square root of 3 over 2. Then I have the cosine of 60, and in this case, that's going to end up being 1/2. I've got the tangent of 60 is going to be the square root of 3. The cosecant of 60 ends up being 2 square roots of 3 over 3. I then have the secant of 60, which is going to be 2, and I have the cotangent of 60, which ends up being the square root of 3 over 3. Okay. So when you're talking about a 30, 60, 90 triangle, you have to be sure that you know which angle is going to be your reference, because 30 and 60 have two very different results when dealing with your trig functions. Alright, so right here, this is just a little note. Typically, when we're talking about these trig functions, You need to use the values in their exact states. And you also need to make sure that you follow your directions. So do keep that in mind the further you end up going in trig. Now let's go ahead and do just a couple examples so you can really see how this works in referencing the rules that we just did. Now for one part, you're just simply asked to find the exact value of this specific function. So I want the tangent of 30. Here's a thing that I always tell students. Draw the triangle before you do anything. Even if you're pretty sure you know exactly what it's going to be, I always recommend that you draw yourself your triangle just so that you can see it. So here we're going to go ahead and do just that. So I'm going to kind of draw myself as close to what might resemble a 30, 60, 90 triangle. Okay, and I'm going to put in my 90. And so then what I know is I know the big angle is usually 60 and the little angle is going to be 30. And then the other things that I can put in is what I know about my sides. So I know that this should have been a 2, that makes this a 1, and this here was the square root of 3. Now the more triangles you draw, the more it's going to become second nature in order to draw them. If not, if you find that you are struggling, do make sure that you reference back to your 30, 60, 90 notes where you have the actual triangle itself, and you would be able to see what the breakdowns of them actually are. Okay. So with this, now that we drew the triangle, we need to know the tangent of 30. So there's a few ways that you approach it. We know that the tangent of any angle is going to be opposite over adjacent. So specifically, we want to look at 30. So we want the tangent of 30 degrees. And so this is going to be opposite over adjacent. So we start with 1 over the square root of 3. We're going to rationalize, so we end up getting the square root of 3 over 3. Now notice in this problem, not once did I actually grab for my graphing calculator and try and do it on there. I do caution you when using your graphing calculators, most of them will give you just a straight decimal answer. And with these problems, we are looking for the exact function. What this means you would be asked to actually show the fraction and the radical, not the decimal. And so in most cases, most professors or instructors would take points off or count it wrong if you give a decimal answer instead of the exact answer. So make sure you read your directions carefully and look to see, are you looking for an approximate or are you looking for the exact? Alright, so now let's go ahead and look at cosecant of 45. So again, I'm going to go ahead and draw that triangle here. So that triangle, remember both side lengths are about the same. And so what we know about it is we've got our 45 in. And so we know that each of these is going to end up being 45 degrees. We also know that each of our lengths was 1, which makes our hypotenuse here root 2. Now the other thing I know is that I want the cosecant of theta, which your cosecant is the same as 1 over the sine, say, of your theta. And in this case, if I looked at sine, I know my sine would end up being 1 over the square root of 2. Now since my cosecant is the flip of that, in this case it would mean that I simply flip this reciprocal. So my cosecant of the 45 degrees is going to end up being the square root of 2. So if you have any questions, please be sure to let me know. This is everything you would need to know to get started with what are called your special triangles. Again, they are the 45, 45, 90 and the 30, 60, 90. So if you need any additional examples or have anything you want to discuss, let me know. Otherwise, I hope you enjoyed, and I'll see you next time.